All right, good morning, Math 110. Today is March 5th, Thursday, and I am not there. So the best thing next to that would be maybe a recording of me there. So here it is. These are notes that you're going to want to write down. Keep in mind that there is a non-calculator portion to the test, and this is a great part that will be on that test, graphing quadratic equations. So what we're going to be doing first is identifying some terms. Every quadratic function has a U-shaped graph called a parabola. The highest and lowest point is called the vertex. So here I have two examples where I have one opening up. Here we would define it as being a minimum value, and one that's opening down where I would have a maximum value. The vertical line that goes through the vertex is called the axis of symmetry, and it looks like that, right? It cuts the graph in half. And that's going to be kind of important when we do sketch these out. All right, so here's the first thing you got to know. If I have a quadratic function, the solutions are the x-intercepts. The x-intercepts are the solutions. So if I give you a graph, and you know that it has x-intercepts of 1, and let's say 3, and it doesn't matter if it opens up or down. Let's say it opens down. Then you know that the solutions are 1 and 3. And vice versa. If I tell you the solutions are -2 and 3, then you know that the x-intercepts are -2 and 3. It's kind of a big deal. Another name for the solutions are the zeros. So I'm going to be you can pause the video or rewind as much as you want, but I'm going to move forward. So what we need to do is understand how the parameter changes the shape of the graph. And a big idea here is the value of a. I can multiply x squared by any number, and what it does is it does two things. It determines if the graph opens up or down, and it determines if you have a narrow or wider graph. Let's try to illustrate. So what we see here is we have y equals x squared. If I make a negative, what we're doing is we are making all the y values negative. So let's go back to my basic quadratic. I'm squaring the output. I'm squaring the input. So that's 4, that's 1, 0, 1, and 4. These are your ordered pairs on the red graph that you see. And let's suppose that I make it negative x squared. That means I make all of the y values negative, which gives me a reflection across the x-axis. All right, so A is negative, opens down, and we would say that has a normal width. What happens if I multiply the y values by 3? So instead of x squared, I can now take all of these outputs and multiply by 3. So that'd be 12, 3, 0, 3, and 12. So graphing that, I'll just graph the easy ones, 1, 3, and -1, 3. So I now have a graph that looks like this. That is 3x squared. It's more narrow. We might say it's taller. Finally, let's say we have a 1/2 times x squared. So if I take all of the original y values and multiply by a half, that'll be 2, 1/2, 0, 1/2, and 2. So let's see, I'll graph 1 1/2. I'll graph 4 2. I'll graph 2 2. And by symmetry, I have some over here. So this is the graph of 1/2 x squared. Notice it's shorter. It's wider than normal. All right. Now let's be more specific with the 3 types. So we're going to have to be able to graph 3 types, and without a graphing calculator. So we have to be able to do vertex form, and we'll do an example of that one. We have to be able to do standard form with an example, and we'll have to be able to do x-intercept form with an example. So here we go. Here's your example of vertex form. You might write this down. It's kind of important. The vertex falls in your lap in vertex form. You're going to find a min or max value based on if it opens up or down, and we're going to find the y-intercept by letting x equal 0 and an x-intercept by letting y equal 0. So all the work we did for solving with the quadratic formula is going to be important. So here's your first example. Take a look at this one. The vertex falls in your lap. The vertex is 4, -5. I change the sign of the inside, keep the sign of the outside. This graph is going to open up because A is positive. The min and max value is the y-coordinate of the vertex. Understand that now. This is the y-coordinate of the vertex. I know what that is. It's right there. So -5 is it's going to be the minimum value because it opens up. All right? So the y-intercept is found by replacing x with 0. So that will be, y will be 2 times 0 minus 4 squared minus 5. It will be 2 times 16 minus 5, which is 27. So that's a large y value that's going to be hard to graph. But the x-intercept is going to be rather helpful. So let's find the x-intercept by replacing the y with 0. So here I have an equation where I can add the 5, divide by 2. That'll be 5 halves equals x minus 4 squared. So then it's going to be the square root of both sides. That'll be positive negative square root of 2.5 equals x minus 4. So then the x-intercepts are plus or minus, 4 plus or minus the square root of 2.5. So the square root of 2.5 is about 1.5. So your x-intercepts are approximately 1.5 and 5, just approximately. Use a calculator if you want to be more accurate. So then I can graph the vertex at 4, -5. I label that with a B. I can graph the x-intercepts at, that's 2.5, at 2.5 and 5.5. And I have a parabola that does that. We're going to notice it's more narrow than normal. It's taller. And the y-intercept won't occur until way up there at 27. All right, moving on. Here is the standard form. The standard form makes you work. There's a lot of plug and chug. There's a lot of calculating and getting numbers correct. So write this information down as needed. Pause the video as needed. What we're going to do is the example. So let's first identify the vertex. Here we go. The vertex is -b over 2a. Well, let's be more specific. The x-coordinate of the vertex is the opposite of b over 2a. That's the opposite of -2 over 2 times -1. A lot of negative signs there, but when the smoke clears, I think we'll get -1. So that's the x-coordinate of the vertex. That's also the axis of symmetry. So we might note that on the graph. All right, let's take that and we'll plug it back in. We'll find f of -1. That is the y-coordinate of the vertex. And so it takes a little bit of work. Let's see, I'm going to get 1 plus 2 plus 8, which is 11. I see my mistake. We got a -1 here, so that's going to be 9. So that is the y-coordinate of the vertex. So let's go ahead and make a note of that. So -1, 9, right here. That is where the vertex is located. -1, 9. We know it opens down. Let's go ahead and note that. So it does open down because A is negative. It does have a maximum value at the y-coordinate. So the maximum value is 9. It's the y-coordinate. The y-intercept, here we go. The y-intercept is found by replacing x with 0. So that's f of 0. And notice it's kind of handy. The first two terms cancel. They give you 0 plus 8. So the y-intercept is at 8. So that kind of makes sense that it would go right here. And then finally, the x-intercept is found by replacing f of x with 0. So 0 equals -x squared minus 2x plus 8. So here's where solving the quadratic equation was helpful. But I do think this does factor. It looks like it does. It should. Factors multiplying through by a negative. There are factors of -8 that add to 2, that's x plus 4 and x minus 2, so x equals -4 and 2. So your x-intercepts are located at -4 and 2, and now I can sketch the graph of this parabola with pretty good detail. Opening down, it has normal width, the maximum value is at 9, and we have intercepts at -4 and 2. All right, last example, intercept form. So this is the factor form. This is where the solutions fall in your lap. The x-intercepts fall in your lap. What does not fall in your lap would be the vertex. So here's some information we need to know. Here's the example. So the x-coordinate of the vertex, you just wrote this down. We have to find p and q. So p is going to be equal to 1, and q is going to be equal to -3. So that's going back to our p's and q's over here. We always change the signs of both. So we're going to be adding those together and dividing by 2. So the x-coordinate of the vertex is 1 plus -3 divided by 2. I think that's -1. So that kind of makes sense because we talked about the solutions being 1 and -3. So if I graph those are the x-intercepts. Let's jump down to the bottom. To find the x-intercept, if I let 0 equal -2 times x minus 1 times x plus 3, I now solve this. It's already factored. So either x minus 1 could be 0, x plus 3 could be 0, so x equals 1 and -3. Those are your p and q values. They're the same. So if I put those on the graph, 1 and -3, I know that by symmetry, the axis of symmetry must be at -1, which would make sense to put the x-coordinate of the vertex on that same line. So then the y-coordinate is found by plugging and chugging. So y is -2. I'm going to replace x with -1. And you got to be careful here. This is going to be -2 times -2 times 2, and I think that is 8. So let's graph that. I don't have room on my graph. I'll kind of slide it up here and call that -1, 8. So that is the vertex. Now I have enough to graph, so let me go ahead and sketch this. I'm still not sure what the y-intercept is. I'm going to guess that it's going to be somewhere around -6 probably. So the y-intercept, we're going to plug 0 into x. So let's see, the y-intercept is -2 times 0 minus 1 times 0 plus 3. And I get -2 times -1 times 3, which is 6. So that is the y-intercept. My graph is a little off because of the scale. So that is 3 examples, one of each kind. We had to do x-intercept form, we had to do standard form, and we had to do vertex form. That completes the lesson for today.